Hello, my name is Susanne Matson, and I'm a practice director for customer insights and advisory at Planit. Before recently joining Planit, I was a Gartner analyst where I advised business and IT leaders on software quality engineering related topics. And I also authored the testing services Magic Quadrant. And I'm here today with Dr. Tafline Ramos, our Global Practice Director for Quality Engineering and Assurance, who has a PhD in software testing. Tafline has over 20 years experience in the ICT industry and is also an international standards leader developing international software engineering standards for ISO. And today we want to share with you what we consider to be 5 quality practices to enable transformation success. But before we get into just what these key practices are, let me give a quick overview over what we see happening in this industry today and what our clients are facing.
Thank you so much. It's so great to be here, Susanne, especially when we're talking about something that I'm so passionate about, which is helping customers achieve greater success in the delivery of their IT systems.
Great. So let's look at why we need these practices and what the key drivers are. At Planit, we interact with our clients every day, and so we see what challenges they're up against as modern businesses. Digital initiatives are accelerating, which is putting more pressure on quality initiatives to be both strategic and innovative. There is growing complexity of business critical systems. Clients are dealing with legacy as well as new technologies, and it's getting harder to manage integrations and end-to-end quality. Consumerization and increasing reliance on digital channels means organizations have to keep up with very high levels of quality to meet high demands for customer experience. And there's also high demands from the business on time to market and speed of delivery. Releases can be weekly, daily, or even hourly, and quality and testing has to keep up. And finally, business leaders are very concerned with security and resilience, and we've seen a lot of damaging cyber attacks on organizations recently. And those are mainly on the business front, but there's also a growing demand from the IT side to modernize product quality, software development, and testing. There is a need for quality and testing to be just as innovative as development and delivery in order to bring more business value to organizations. So some key trends to be aware of in order to make quality work harder for you. We see more modern development practices such as Agile and DevOps methods to increase speed and flexibility in organizations. And this has an impact on quality and testing. Agile is part of the solution in integrating quality into the process, but Agile also creates silos in larger organizations where each Agile team is delivering a separate system and nobody is looking after the end-to-end. End-to-end integration is critical in Agile and should be supported by quality. There is a shift towards more of a culture of quality being adopted in companies. Quality is strategically important and is being recognized as the responsibility of all teams across the life cycle. There is a desire among many organizations to start the quality-focused activities earlier in the life cycle to make the process more effective and to avoid creating bottlenecks. In addition, the move to the cloud has naturally increased demand for cloud migration assurance and continuing assurance of software as a service applications. Data and analytics, that's a key area as there's enormous opportunity in the data that can be gathered. On the other hand, there are multiple restrictions and regulations in how you gather, maintain, and use that data. How do you gather test data without compromising these laws and directives, for example? And finally, another hot trend in quality that we see is about making quality smarter. So how you can amplify the testing and quality process with new technologies like RPA or AI or machine learning. This is very early stages, but do watch this space as we expect to see much more of this in the next 2 to 5 years or so. So that was really just setting the context very briefly, but now I would really like to invite you, Tafline, to please share with us the first quality practice that you think is key for transformation success.
Thank you so much, Susanne. So the first practice is really looking at how to transform your organization's investment in quality from just pure testing across to quality engineering. And if we look at what that means, testing really is primarily about finding defects. It's also about building confidence that we're delivering a good quality system and confirming that business requirements have been met. But testing in itself occurs quite late in the life cycle, after the requirements have been written, after the design and the architecture has been assembled, and after the code has been built and configured. And it's too late really to find out whether or not your system is going to meet those quality requirements. It's important, but we need to invest earlier. Quality assurance includes all of the practices we implement in testing, but it extends beyond that to shift quality to the left by reviewing the upstream artifacts that we're producing before we build the code. That is, reviewing the design and the architecture, reviewing the requirements that go into that design and architecture, and then, of course, reviewing the code as it's being built. So that when we test the system, ideally, it's already meeting its requirements, and we can spend less time getting stuck in rework and spend more time confirming that the product is actually ready to go live. And ideally, reducing our investment in quality in general as a result. Quality assurance is also about improving the life cycle that we're following. So when we find a defect, quality assurance looks at why that defect slipped through, especially if the defect is found quite late in the process. And it's about improving that life cycle so that the next time round, we produce better quality. Quality engineering extends beyond both testing and quality assurance to deliver an optimized life cycle that builds a whole team approach to quality. In quality engineering, we're looking to build quality into the system by evaluating the requirements, evaluating the design, and evaluating the code before we test that code. So it is about all of the shift left practices that we would do in quality assurance. But quality engineering is also about shifting quality to the right. So it's also about looking at the quality of our release management processes, our operations processes, and even our support processes and maintenance processes to make sure we are evaluating quality and testing whether quality is present as early and as frequently across the full life cycle as we can. Really, the goal is to reduce business risk by evaluating quality sooner and really reducing the overall cost of quality and the time it takes to deliver the system.
So I can definitely see the benefit of getting things right the first time, but what are the real wins of utilizing a QE approach?
Great question. So in quality engineering, not only are you delivering faster and cheaper, it also ensures you're delivering the right product in the first place. It ensures you're actually getting the requirements right first time, so that when you deliver that product, you're delivering and really maximizing your business value and really maximizing your return on investment for your spend on quality, and with much less business risk. When we talk about business risk, it's about reducing the kinds of risks that can potentially cause brand damage or business damage and even impact to customers, such as the security and the reliability risks that you mentioned earlier. And really, it's about improving your confidence from the start. So not waiting until you test the system to find out if it's looking good and looking ready for your business and for your customers, It's about improving your confidence right from the start so that you don't have to wait until just before go live to find out if the software is going to deliver what you need.
That's brilliant. Can you please tell me also about the next 4 quality factors that are keys to transformation success?
Yes, absolutely. So the next one is about risk-driven quality, and that is risk-driven quality is a shift-left approach that reduces the likelihood that the software will fail once it's in front of the customer. And it even reduces the likelihood that your project might fail to deliver quality. So in risk-driven quality, we're working on a whole team approach to identifying how we can build quality into the system and how we should test the system. And we base those decisions on the types of risks that we think the system may suffer when it reaches production and when it's in front of the customer. We then work backwards from that to choose the right approach to quality engineering, quality assurance, and testing across the full life cycle to make sure we're balancing our investment in quality and only investing in what we think is going to mitigate the risks that really matter to our business. And that allows us to make sure we're not overspending, and it also means we're not going to underspend in our delivery of quality and testing practices.
I understand. So I heard you mentioning the words shift left as you were speaking. Can you tell me more about that, please?
Definitely. So really, when we talk about shift left, we're talking about detecting defects earlier and as often as we can across the life cycle. Shift left is the focus on finding defects during the requirements phase, during our design and architecture phase, and during our coding phase, so that when we do test the software, we're really confirming that the system meets its requirements. We're not spending as much time having to retest, report defects, and have rework in fixing defects and retesting the software. Really, shift left is about getting it right first time so that when we test the software, it's already doing what it needs to do. And really the motivation behind that is that the sooner you find a defect, the cheaper it is to fix that defect. And if you have a look at, what we call the typical cost of quality curve or the cost of defect repair curve, a defect that's found in the requirements phase is very quick and easy to fix. We can find that defect by simply reviewing the requirements and inspecting the requirements and looking at that end-to-end system that we're building and asking ourselves whether the requirements are complete, consistent, and specify all of the features that the business and that our customers are going to need. Fixing a requirement defect can be as simple as just hopping into your requirement management tools, such as hopping into Jira, and updating the user story that specifies that requirement. It's a really simple, quick, and easy way to improve quality early on. That then prevents those defects from creeping into the design and creeping into the code. Now compare that to a defect that's found quite late in the life cycle, perhaps during acceptance testing. By that time, you've got business users or end user representatives testing your system. If an end user or a business user finds a defect during acceptance testing, a tester usually has to support that business user in documenting the defect. That defect usually has to then be sent up to the product owner or a project manager or someone senior in the team to say, is that a real defect from a customer perspective? And how much does that defect matter? Is it one that we truly need to fix now? Or could we patch it in a later release if it's not going to be seen by a customer anytime soon? Once that defect has been reviewed, if it's going to be addressed now, it has to be sent across to the development team, which could be a separate third-party development vendor. The defect is typically reviewed by a senior developer to determine the nature of the defect. There may need to be additional communication with the tester or the business user to clarify the defect. Then a developer needs to fix the defect and retest the defects themselves. They then need to hand that defect back across to the tester. The tester retests it, followed by the business tester retesting it. And it's a really long process of rework that you can get stuck in, especially when defects are found quite late in the life cycle. Now compare that to a defect found in production once the system is live and in front of real customers and real business users. A defect found in production can often cost at least 30 times more to fix than a defect found in the requirements phase. And if you extend that out to mission critical systems and safety critical systems, in fact, the cost of fixing production defects can be quite astronomical. It can be more like 100 times more or even 1,000 times more to fix than a requirement defect. So really, shift left is all about finding defects as early as possible so we can reduce rework, get it right first time, reduce the cost of delivery, and accelerate delivery to production.
So, given all of these different considerations that you've just talked about, and that the speed of delivery is now becoming even more important, how can we solve this equation?
Yeah, definitely. Really important consideration. So that's really the fourth factor that I wanted to talk about today. One of the key ways we can accelerate delivery is through strategic and intelligent automation. Strategic and intelligent automation is really about building automation tests that focus on automating the right tests in the right tool set, and ideally an integrated tool set that then gives you much greater visibility of the level of quality that's present and the level of confidence you can have in the software as it's built. And it's also important to measure how well we are doing in terms of implementing the right automation tests to make sure we get the right return on investment and greater business value in our investment in quality.
So I think you made an excellent point about measuring the value of your improvements as you go. Can you please tell us more about that?
Definitely. So really that's the fifth factor to consider when looking to implement quality practices to improve your success of releasing high quality systems to production, particularly in large transformation programs. The final factor is collecting metrics to measure how well we are doing at improving our life cycle. So remembering that quality engineering is not just about implementing quality assurance and testing processes across the full life cycle. It's about building an optimized life cycle by implementing the right techniques at the right time. In order to know whether we have optimized the life cycle, we need to measure before we make any changes. We need to measure the cost of our delivery, the speed of our delivery, and the quality that we are achieving before we make the change. Once we start implementing new quality assurance and testing practices across that life cycle, if we've collected metrics before the change, we can then compare back later to determine how much of an improvement we've achieved. Really, we want to make sure that we are maximizing our return on investment and maximizing the level of business value we've achieved through implementing quality engineering practices. And at Planit, we tend to collect a lot of metrics on our programs of work and projects that we do with customers. We want to make sure that we are delivering the kind of cost savings that the customer is aiming for. And it can be time savings, it could be cost savings, or it could simply be improving quality in the released system. Some of the examples of the types of cost savings we've achieved for our customers are, for example, implementing early life cycle improvements, such as reviewing requirements and helping to shape better quality requirements. Those early life cycle practices can result in a 20% reduction in the overall cost of building that product. Because if you've got the right set of requirements in the first place, then you're not going to have as much rework because you'll build the right system in the first place. Other savings we've achieved, for example, through automation, is a 40% reduction in the time it takes to regression test the system after changes made to the system. And that's really important for any customer that wants to really accelerate delivery, not just reduce the cost of delivery, but really accelerate delivery and get more releases to their customers sooner.
Thank you. So I can really see how modern businesses can adopt quality engineering to overcome many of the challenges that they have in modernizing and transforming their businesses. So Tafline, thank you very much for sharing these 5 practices with us today. So for those of you that don't know Planit, we are a global company and the largest quality engineering services company in ANZ. We are experts in quality engineering and testing that support our clients in ensuring that you build quality in from the start and that you take the right approach in balancing quality and risk to make organizations resilient and secure and with great customer experience. And we have many experts, just like Tafline that just spoke to you, that are implementing these processes and other processes with our customers. So we thank you very much for listening, and please do get in touch with us at Planit if you need our guidance and support on any of these practices. Thank you.
Thank you so much.